Hi everyone, so in this video we talk about the combinatory analysis. So as you know, combinatorics gives the mathematical shortcuts to instantly find the total number of possibility without ever having to write a single one down. So we don't need to count them one by one. So combinatorics is the absolute engine that makes probability works, and as you know, um, we saw this in the first videos. So the probability of an event to happen is the number of favorable outcomes divided by the number of possible outcomes. How to get those numbers? By counting, and combinatorics helps to do this in a simple manner. So we have different cases, and based on two different conditions, the repetition is allowed, and the second condition is the order. Does it matter? So we start with the first case. So when we have the repetition allowed and the order matters, so we get this, what we call the variational repetition or the p-list. So let's see what is the formula and how we got this formula. Actually, the formula is here: n power r, n power r. Example, if I want a 4-digit pin code from 10 numbers, I get this, the total, the number of ways I can do this. So it is 10, which is the available, our n here, available numbers from 0 to 9, power 4, which is r. R here is 4. It is the number of digit in our code. So 10 power 4, we have 10,000 ways to do this. So let's explain why it is n power r. Actually, for the first, we said we take this example, but this time imagine I have n is 4, n is 4. I have only 4 available number from 1 to 4, 1, 2, 3, and 4, and r is 3. I want a code pin with 3 numbers. So my first number can be 1, can be 2, can be 3, can be 4. Now the second level, which means the second number, could be also, if the first is 1, the second can be 1, can be 2, can be 3, can be 4. Same thing here, if it is the first is 2, so we can get in the second number 1, 2, 3, 4, 4, and same thing for this. It can be 1, it can be 2, it can be 3, it can be 4. Same thing here. So it is 4 times 4 times 4 times 4. This is for the second level, the second number. Now if I want a third number, so if the first is 1, the second is 1, the third can be 1, can be 2, can be 3, can be 4. If the first, so I have here 16 case, so each case now will be multiplied by 4. So again time 4. If I need 4 number, I will also multiply it by 4. So it is simply 4 times 4 times 4. What is 4? Is n, our available number, which is from 1 to 4. Power r times how many times we multiply it. So it is the number of the digit I include. So here we said if it is 2, I need only 2 numbers, so it will be 2. 4 power 2, we get 16. But if I need to use 3 numbers, so it will be 4 power 3. Now the rule is here. This is the rule. So if the repetition is a lot. I can repeat the number, so I can get 1 and 1 and 1. And if the order matters, which means 1, 2, 3 is different from 2, 1, 3. Here the order matters. So we get what we call p-list, or the variation with repetition, and the formula is n power r. Now let's move to the second situation, when we have the order matters, but the repetition is not allowed. Here what happens actually, let's take our example. It is same thing as we did with the playlist, but here since we cannot repeat, we said here no repetition is allowed. Since it's not allowed to repeat, here we cannot put 1 here. Cannot put 1 because 1 is already here, so we cannot add it here. So once we got 1, the next level for the second, we can only choose 2, 3, and 4. So we need to remove 1. So here also, if we got 2, we cannot use it again, so we use 1, 3, and 4. Here if we got 4, we cannot use 4 again, so we use 1, 2, and 3. So for the next level we need to subtract 1, so it is 4 times 3. And then if I want again another number, so for example here the first number is 4, the second is 3, the third cannot be 4, cannot be 3, it can only be 1 or 2. So again we multiply by 2. So what is 4? We said it is our n. What is 3 is n minus 1. What is 2 is n minus 2. And we keep subtracting 1 until we achieve a number. This number is actually n minus r plus 1. We stop there. We stop at n minus r plus 1. For example here I wanted 3 numbers. So I kept subtracting 1. So 4 minus 3 minus 2 until 2. I stopped at 2. What is 2 is n, which is 4, minus r, which is 3. I want 3 numbers plus 1. So it is 1 plus 1, we get 2. I stopped at 2. So this is the rule. We stop at n minus r plus 1. Now let's write it again. So this is our formula, and we can multiply this by this factor, which is actually 1, so it doesn't change this. Now after multiplying this by this, we can get something. So it becomes n minus 1 until n minus r plus 1, then n minus r, which is this minus 1, which means we keep subtracting 1, and here it is factorial, which means I can write it like n minus r minus 1, n minus r minus 2, and so on until I achieve 1. So instead of this I can just write it like this, which is the same as n factorial divided by n minus r factorial. And this is our formula. This is our nice formula we use when the repetition is not allowed. And actually this is called the arrangement. The arrangement is this is the notation, a and r from n. So the formula is n factorial divided by n minus r factorial. We have a special case when we use all the available here elements. For example, if n, that means I use r, which is the same as n, so n equals r. When n equals r, if we apply this formula, we get n divided by n minus r, while n equals r, which is 0 factorial. We know that the 0 factorial is 1, so in the end we get the what we call the permutation. So a special case of arrangement when n equals r is called permutation, and the notation is like this: Pn equals n factorial or r factorial, same thing, because n, we said, is equals the r, as explained here. Now another condition is when the repetition is not allowed, just like the arrangement, but this time the order also doesn't matter. The order doesn't matter. That's what we call the combination. And let's back here. What does it mean the order doesn't matter? It means here 1 and 2 and 3, here is the same as 1 and 3 and 2, because if the order matters, that means 1, 2, 3 is different from 1, 3 and 2. So here we have two ways, but if I say the order doesn't matter, instead of 2 it is only 1. And now let's see in how many ways can we arrange this number. Let's say, for example, 1, 2 and 3. In how many ways can we arrange them? I have 3 numbers, I use them all. So we are in this case, which is permutation. I have 3 numbers, I arrange them, so I get the factor of 3, which is 6. 3 times 2 equals 6. I have 6 ways to arrange this number, like this, and so on. So we have 6 ways. But here, if I say that the order doesn't matter, all these 6 ways becomes only 1. So to find actually the combination, when I say the order doesn't matter, the combination, we call it combination R from n, it is simply the arrangement, but this time we need to divide this arrangement by the number of permutation that we got from R, which is the factorial of R. We know that the permutation is R factorial. So this is the final formula for the combination. How we got this? We know that. So this is the arrangement. If we divide this by R factorial, we get this nice formula. And here again, so the combination of R from n is the factor of n divided by the factor of n minus r times R factorial. Now an example, a good example here is choosing 3-person team from 20 students. Here we cannot repeat, which means I cannot take one student twice. Also the order doesn't matter since they don't have specific job. So if I choose the first student or I place it as the second or the third, it doesn't change anything, so the order doesn't matter. Now we have another case, which is permutation with repeated items. Here, if for example I ask you to find how many words can I create using this word, which is pepper. Here you may think that since I use all the items, it is a permutation. Yeah, it's a permutation, that's true. But there is one problem here. If you say it's permutation, that means it is the 6 factorial. I have 6 elements here. But one thing is here is that P is repeated 3 times. E here is repeated twice. Let's take a look at E. So E is like this. So I can get this E with E, and this is one way. I can start from this E. I take this E here as before this. So this is the second way. So if I use this formula, it's like I said, this E is different from this E. Okay, E and E. It's like they are different, but no way, they are not different. So I need to divide by the number of permutation of E. So the number of permutation is how many times it is repeated, which it becomes our R. So and 2 factorial. Now same thing for P. So P can be arranged in 6 different ways that are all the same. So we need to divide by 6. What is this 6? Is actually the n1, the number of repetition, which is 3 factorial, because it is the number of permutation. It is the number of the ways I can arrange my 3p here. Since we said we have 6 ways to arrange our p, and all of them are the same, so we need to divide by 6, which is we find it by doing the number of repetition, which is 3 factorial. So in the end, the formula here is, so you do the decomposition, our items. Each item you find the number of repetition. We have 3p, we have 2e, we have 1r. And then we apply our formula, which is n factorial divided by what? Divided by the factorial of each repetition, the product actually. So it is Pn here equals 6 factorial, n is 6, the total, divided by 3 factorial, the number of repetition of P, times 2 factorial, which is the number of repetition of E, times here 1, which is 1, so no need. This is why we include only those repeated from 2 and above. So that's what we call the permutation with repeated items. In the end, you have another situation where the order doesn't matter. So it is like a combination, but in this case the repetition is a lot. So the formula is simply like the combination. The only thing that changes here is that the number of available items is not n anymore, but it is n plus r minus 1. So that's the only thing that changed. And the good example for this is like buying 4 donuts from 3 flavors. Here the order doesn't matter. You put like strawberry first, or blackberry second, or you start with blackberry, it doesn't matter at all. And the repetition here is allowed, which means you can buy 2 strawberry and 1 blackberry flavor, and you can buy 3 of them are BlackBerry, etc. So here the repetition is allowed, but the other doesn't matter. This case called combination with repetition, and as I said, it's almost the same. The only thing you change here is our n, our available items, is not n anymore, but it's n plus r minus 1. So this is all about the combination. Thank you for watching. In the next video we will see the conditional probability. Goodbye.